Welcome back to this next part of the seminar. Before we start, I want you to sit back, think a bit of what you've learned. Be sure that you are biologically replenished. So just push pause now and reflect for a moment. I assume that you are back, that you pressed play, and that we can continue with this part of the seminar. Let's look at the next slide. So to innovate properly, the hippocampuses, which you see here in the 3D model, need to ship out the properties of knowledge to so-called long-term memory sites. And what is very fascinating about this process is that it happens mostly at night, and this is why we need to sleep, so we consolidate memory. And what is quite interesting as well is that these long-term memory sites also correspond with the areas of primary sensation. I'll explain that. We don't see with our eyes, we see with the back of our heads. And so if you hit your head against the wall, you will see stars. Why? Because you really see stars, right? It's the occipital lobe, the back part of the brain, which is activated and therefore show you little stars. It's also what happens when you have migraine of a certain type, when you see these little stars and bizarre spectra in front of your eyes. It's not the eyes that are showing you this, it's actually the brain. And so it's the primary visual cortex that really we see with. And so we make sense of what we see with by means of integration of shapes, sizes, colors, and movement. And so that gives us an integrated picture of what is out there, a so-called internal representation of what is out there. So the visual components of knowledge, for instance, the knowledge of an apple, that an apple is red or yellow or green, that resides once again in the occipital lobe in the back, where we also have primary sensations and senses of the visual components of what is out there. And so you can see what is demonstrated here in these grey blocks are the long-term memory sites that correspond also with the primary sensory areas: hearing, vision, touch. We didn't put smell and taste in here, and there are many other senses, as you know, but they are not the primary senses. And so once you have all these properties of knowledge stored in these right places, your problem-solving brain is ready now to use those properties and piecemeal them together, assemble them to make realistic scenarios of the possible. And this is exactly what we see in the next slide. You can see these orange tracts, these pathways. There's a connection now from the long-term memory sites to the dorsolateral prefrontal cortex, which is the top outside part of the prefrontal cortex. So the most sophisticated part of the problem-solving brain are these orange blobs in front. These areas called the dorsolateral prefrontal cortex. They are connected through a number of pathways. In fact, there's a big pathway on the right and a big one on the left, and they are connected through this colossal body, this big body of connecting fibers that connect the right and left brain, called the corpus callosum. And these pathways, these major pathways, are called the superhighways of the brain. And the superhighways of the brain connects these long-term memory sites with the prefrontal cortex to ensure that we use these building blocks of innovation, these knowledge bits, and assemble them to make realistic scenarios of the possible. Abstraction takes place along these superhighways, and there are a number of things that are very important in the dorsolateral prefrontal cortex, so-called executive function, to ensure that everything works properly and that we innovate at our best. I almost want to say ad break, and just look at this this beautiful picture that says so much about how we enable ourselves to learn about the physical world. Effectively, we make the big world small when we are young. We play with little toys like cars and buildings, and we use building blocks to build buildings and shapes, etc., etc., for two reasons. One is we enable ourselves in this logical, mathematical part of our brains to understand the properties of the physical world, the three dimensions in space and also time. And so this is really laid down very, very early in early years. And for us to understand the big world out there, we make it very small when we are young, and then we play with it. And so right from this age, you and I started to make internal representations of what is out there. And we did it very systematically, almost milestone fashion-like. And eventually we built one bit of more sophisticated information on top of the less sophisticated and more basic knowledge. And this is almost like a scaffold. As you build a building, the brain builds upon itself, and eventually you and I have the capacity to not only make realistic scenarios of the possible, but also to provide those scenarios into accurate and realistic solutions, and even fashion novel products that stem from that. And it's all based on this capability of making accurate internal representations of what is out there. So the brain enables us to make accurate internal representations of what is out there, very much in the same way that we do not actually see with the eyes, we see with the brain. We hear, we feel, we touch, we smell, and so we make internal representations of the physical. We also make internal representations of the emotional, and if you may, of the spiritual, and we put all of this in an integrated, systemic fashion way together, and then we use this knowledge to guide ourselves safely through life. And this is innovation. So back to the process. If you look at this guy who is trying to assemble a car and all his properties and components, once again you can see through his head into the brain. You'll see these yellow blobs which represent the long-term memory sites. You'll see this arrowed pathway which is called the superhighway, and you'll see the prefrontal cortex, the so-called dorsolateral prefrontal cortex in the front of the brain. And this abstraction process really exists of two different processes that take place all the time while he is trying to figure out how to make a realistic scenario of the possible, and then converge that into a solution. And these two processes are divergence and convergence. And divergence also speaks a bit to lateral thinking, the what if. It continues to bring in new information, the what ifs, and it builds all kinds of potential components, if you may, a very rudimentary scenarios of the possible, which is then converged into something that is simplified and becomes a solution. And it's continuously happening along this pathway, the so-called superhighway of the brain. And there are neurotransmitters in these pathways which are secreted, amongst others dopamine, which is very important for this process. Back again to this by now well-known picture of prefrontal regulation. Remember that to make realistic scenarios of the possible, the prefrontal cortex uses its connections through the superhighways of the brain with the long-term memory sites, where it uses the properties of knowledge, use these building blocks and assemble them into realistic scenarios of the possible. So abstraction can be enhanced. This divergence and convergence can be enhanced, and there are a number of simple practical things that you can do. Remember this from your brain performance seminar on abstraction and your recommendations. As a team, be sure that you assign someone to ask the what if question all the time. Assign this task of asking the what if question to one team member during your meetings. And maybe there is one who does this all the time. Utilize that process, and be sure that you think about the what ifs, so that you can enhance your lateral thinking, the abstraction capabilities, and especially the divergence. Be sure that you're curious, enhance curiosity, ensure that you learn more, so that you can expand the world and provide more building blocks for the abstraction process. And then use the generic parts technique. The generic parts technique is the capability, or the technique provides you with the capability to solve problems probably about 60 percent plus better than before, or you solve about 60% more problems with the generic parts technique, and this has been shown in science. And what you do is you break up the problem into its smallest parts, sit back and allow the unconscious to assemble these little parts into a realistic solution. Back to the prefrontal cortex. In the prefrontal cortex, there are a number of very important characteristics of so-called executive function that allows the prefrontal cortex to work optimally. The first one is sustained focus and attention. You can see this little white dot with the dartboard effect around it, ripples. You can see that we need focus and sustained attention on a problem to be able to solve it. And here is a little paradox. We tend to think of focus as a conscious process. Yes, we do have to focus consciously when we are thinking about a problem or when somebody is telling us something. Sure. Focus and sustained attention is a vastly unconscious process. You focus on a problem while you are sleeping, and to enhance the focus capabilities, you have to have heightened awareness and to ensure that your brain-body system is optimized, especially the wellness rhythms and your social safety, so that the brain does not pay attention to basic cues that are threatening its survival, and so that the prefrontal cortex can be utilized at its best. So your prefrontal system pay the attention to the problem and has more focus and energy to assign to the problem. And it's done unconsciously. Remember, we solve our most complex problems during sleep. So focus and sustained attention is the first important component of the executive function system of the prefrontal cortex that I want to just point out to you. The next important feature of this executive function of the prefrontal cortex I want to consider with you is called working memory. Working memory is not the same as other forms of memory. The other forms of memory that you and I know very well effectively gives us knowledge. So this is knowledge of the world, knowledge of objects, knowledge of events, and this is also called short-term memory, which becomes long-term memory, etc. But working memory is something else. Working memory is the capability to hold a amount of objects or thoughts in the consciousness or effectively just in the subconsciousness on a conveyor belt as it runs past this prefrontal cortex so that it can be used to solve problems. If you think about it, if you have been taught these are the properties of the problem, now solve the problem doing this. There are a sequence of two events. The first is you are provided with information. Then you have to do something with the information. Then you have to do something with the information follows after you have been provided with information. And that information therefore needs to be a working memory so that you can keep it there so that you can solve the problem with it. And if you do not have a good working memory capability, you will not be able to utilize anything because in phase 2 of this sequenced challenge, you didn't have any capabilities left to recall what was in phase 1. And so this is called working memory. It's almost like information is being presented to you on a conveyor belt and it's running past you, and once you've used it, it is forgotten. It's a bit like remembering a telephone number. And then you dial this number and then you forget it. It's probably a good analogy of working memory. It's been held that we can hold 4 objects in our prefrontal cortex available to solve problems at a time. There's a lot of controversy around working memory. At least we believe this can be enhanced, and the capabilities of utilizing objects and concepts and constructs so that we can solve problems with it is not as linear as just being objects. It's a very complex feature of the prefrontal cortex, and it can be enhanced. And I'll get to that just later. So just bear in mind, focus and sustained attention, working memory, and the next component I'm going to talk to you about, or the feature of the executive function of the prefrontal cortex, is reduced latent inhibition, coming up. At this point, I want you to take a break. We will continue in the next part at exactly the same point, and we will continue to build the seminar, and so the three parts will stand together as a continuum of effectively one topic being dealt with efficiently. But take a break now, just relax, move around, and just come back to the next part when you are ready and replenished again. Don't forget, you are a biological system, and you need these periods of rest in between.